Good morning to all. We'd like to take the another application, door locking alert system. Indeed, it is useful for the driver to know whether the doors are properly locked or not. If any one of the door is not locked, we can say it is open, then some alert is to be given. So this is a four-wheeler. These are the windows, these are the doors, and the alert is to be given to the driver. Alert is nothing but a warning, and when any one of the door is not locked, alert is should be given. So this system is having basically four inputs. Because four doors are there in the vehicle, D1, D2, D3, D4, and the alert is to be made or not, one output, and basically it is a multi-input single output system. We say the door status dx, that x can be 1 or 2 or 3 or 4. So you can say 1 less than or equal to x less than or equal to 4. D1, D2, D3, D4. If D1 is 0, door 1 is closed. D1 is 1, door 1 is open. Similarly, D2 is 0, door 2 is closed. D2 is 1, door 2 is open. D3 is 0, door 3 is closed. D3 is 1, door 3 is open. D4 is 0, door 4 is closed. D4 is 1, door 4 is open. So 4 doors, we can put it in one simple expression. So what is our common sense says? Any one of the door is open, alert should be given. So not locked, open, not closed, all of them are going to be same. In other words, if any one of the input is 1, that is either D1 is 1 or D2 is 1 or D3 is 1 or more than one door is open, the concerned alert should be made. It is simply OR operation. D1, D2, D3, D4. Any one of the input is 1, output is 1. Any one of the input is 1 means any one of the door is open. Output is 1 means alert is given. Normal. We would like to construct the truth table from the behavior of this system. Since there are 4 doors are there, we can have 16 input combinations. And their decimal values are varying from 0 to 15. If D1, D2, D3, D4, all of them are 0, obviously what it tells, all the doors are closed and hence no warning is to be given. If it is 0001, D1, D2, D3 are closed and door 4 is open, hence warning is to be made or alert is to be made. 0010, door 3 is open, alert is to be given. 0011, both the doors D3 and D4 are open, hence alert is to be given. 0100, second door is open and hence alert is to be given. 0101, door 2 as well as door 4 are open, alert is to be given. 0110, door 2 as well as door 3 are open, hence alert is to be given. And 0 triple 1 means D2, D3, D4 are open, hence alert is to be given. So likewise, for all the subsequent combinations, either one or more than one doors are open, hence alert is to be given. So all these cases we are giving alert because it denote one or more doors are open. Now we want to write a Boolean expression for this door lock alert system, DLA. This is the truth table for door lock alert system. Okay. In order to write the Boolean expression, you can express either sum of product expression or product of sum expression. Again, I recap what we have discussed in the previous lecture. The sum of product expression, it is the collection of mean terms. Sum of products. And the sum of product expression associate the mean terms. And what is a mean term? Input combination for which output is 1. In the previous description, we have shown that out of the 16 combinations, 15 combinations are having output is 1. For these 15 combinations, we can write a sum of product expression. So obviously it is written as sigma m. M stands for mean terms. And what are the input combinations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 combinations are representing the mean term. See, G1 is there. The binary pattern for 1 is 0001. D1, D2, D3, D4. Now when I'm writing, expressing it as a mean term, it should be written as the product of input variables such that the product is 1. So I have to write obviously D1 prime because 0 into D2 prime, again it is 0 into D3 prime, again it is 0, and finally D4. This is a product representing the input combination 0001. This is one main term. So like that, the main term 2, it is 0, 0, 1, 0. Main term 3, 0, 0, 1, 1. So like that, we can write the 15 combination, 15 main terms, and we need to perform the sum operation. Hence, it is declared as sum of product expression. Now we consider product of sum. So out of the 16 combinations, 15 combinations output is 1 and only one combination for which output is 0. Hence we can say it is associating single max term and rest of the 15 are going to be the main terms. So max term is the input combination for which output is 0. We should express the max term as sum of the input variables. Max term is sum of the input combination or variables, so that total value of the sum is 0, or we call it as output. Okay, so max term is 0, and hence what is the binary pattern associated with the 0? D1, D2, D3, D4, all of them are zeros. And hence I can write it as 0 plus 0 plus 0 plus 0. Obviously the result is 0. And how to write it? D1 plus D2 plus D3 plus D4. Interesting. For main terms, 0 stands for complement form. For max term, 0 stands for normal form. Once again, for a main term, 0 stands for complement form. D1 is 0, it is D1 prime in the expression. For max term, 0 stands for normal form. That is, 0 is there, I have to write it as D1. Again, D2 is 0, I have to write it as D2. 0 is there for D3, again I have to write it as D3 for sum. And 0 is there for D4, again I have to write it as D4 for a sum. So the total value of the sum must be equal to 0. So if you consider this and use the gate, it is a simple OR gate is capable of providing solution. And if I write it, y equal to D1 plus D2 plus D3 plus D4. Okay.